Imagine a world where advanced alien civilizations exist, but they are trapped on their own planets, unable to explore the cosmos. What could be holding them back? Space junk might be one of the things holding them captive. They might even be more advanced than us, but still can't overcome this challenge. Whether it's a technological barrier, a limitation imposed by their own biology, a fundamental law of physics we have yet to understand, or perhaps some mysterious planetary conditions, their inability to conquer this obstacle could have profound implications for our own future in space exploration. What if the same fate awaits us as we venture further into the cosmos? Stay tuned as we delve deeper into this intriguing mystery. We will uncover the shocking reasons why this situation might exist. So, aliens, huh? According to statistics, there should be millions of technologically advanced alien civilizations just in our own galaxy. Yet, we have seen a whopping number of 0 aliens so far. So where the hell are they? Are they hiding from us? This, my friends, is called the Fermi Paradox. No one knows why we haven't seen any, despite statistically speaking, there should be millions of them. Maybe they really are hiding. However, I think it's unlikely. Personally, I think they're just stuck on their planet. After all, space travel is hard, especially interstellar travel, even for an advanced civilization. If aliens are unable to leave their home planet, several scenarios and implications arise. For example, they could be blocked by pre-existing space junk. Previous attempts at space travel might have led to the accumulation of significant debris in orbit. Failed missions, defunct satellites, and remnants of rockets could create a dense field of space junk. The debris might pose a high risk for any new spacecraft attempting to reach orbit. Collisions with even small fragments of space junk can cause catastrophic failures, leading to the destruction of the spacecraft. Also, extensive use of near-planet orbit for satellites, research stations, and other structures might have cluttered their space environment. This dense network of objects can form an almost impenetrable barrier to safe launches. The presence of numerous artificial objects in orbit increases the chances of collisions, generating more debris and exacerbating the problem. This cascade effect, known as the Kessler syndrome, could render certain orbits unusable. The civilization might lack effective measures for debris mitigation and management. Without technologies or protocols to remove or avoid space junk, the problem continues to grow. Technological limitations might prevent them from developing solutions to clear or navigate through the debris field safely. The inability to safely launch new missions would stall their progress in space exploration. This could hinder their scientific advancements and limit their understanding of the universe. Significant resources might be diverted to address the space junk problem, taking away from other scientific and technological pursuits. Another reason why aliens might not be able to leave their planet is due to environmental constraints, which can significantly hinder or even prevent the development of space travel. These constraints can be broken down into several key factors. Maybe their planet is larger than Earth and therefore has more powerful gravity. Planets with much stronger gravitational pull than Earth require a significantly higher escape velocity to overcome gravity and enter space. This means that any spacecraft would need to be exceptionally powerful and carry much more fuel, which could be technologically challenging and economically prohibitive. The immense energy required for launch could make regular space travel unfeasible. Also, the materials and structures needed to withstand extreme gravitational forces might not be readily available or may not exist at all, making the construction of viable spacecraft highly complex or impossible. Moreover, imagine a scenario similar to the movie Interstellar, where a planet orbits close to a black hole. By the way, if you haven't seen Interstellar, you should give it a chance and watch it. It's awesome. So, back to the topic. The intense gravitational forces from the black hole would complicate space travel even further. The time dilation effects and the extreme tidal forces would pose unprecedented challenges. Any attempt to launch a spacecraft from such a planet would not only need to overcome the planet's gravity, but also navigate the complex gravitational environment created by the black hole. The technological and engineering demands for such a mission could be beyond the capabilities of even the most advanced civilizations, trapping them on their planet despite their advancements. Another factor might be that the planet has a very dense atmosphere, which would increase aerodynamic drag, requiring spacecraft to expend more energy to reach the necessary speeds for orbital insertion. This could also lead to higher rates of fuel consumption and increased wear and tear on the spacecraft. If the atmosphere is composed of reactive or corrosive chemicals, it could severely damage or degrade spacecraft and equipment during launch. The need for specialized, highly resistant materials would further complicate space travel. Another scenario might be that their planet is not as technology-friendly as Earth. It's possible that planets with environments as calm and with easily accessible resources as Earth are very rare in the universe. Frequent or unpredictable volcanic activity and regular or severe seismic activity could similarly disrupt and damage infrastructure, making the maintenance of a stable and secure launch facility very challenging. It's like trying to build a sandcastle on a beach during a hurricane. Good luck with that. Or maybe they evolved on a water world, and developing technology underwater is not possible. These environmental constraints could severely limit the ability of an alien civilization to develop and sustain a space program. The additional technological and economic burdens imposed by these factors might render space travel impractical or impossible, confining the civilization to their home planet despite their technological advancements in other areas. Like us humans, the aliens might have some biological constraints preventing them from space travel. Their biological requirements may be very difficult to meet outside their home environment, such as specific atmospheric composition, gravity, or radiation levels. They might be particularly susceptible to the effects of microgravity or cosmic radiation, making space travel hazardous to their health. Additionally, the stress of space travel and isolation could exceed their mental tolerance, making long-duration missions unfeasible. Technological limitations are also a possible reason why we haven't seen any aliens traveling through space. Maybe the emergence of ultra-advanced technological civilizations is impossible or hasn't happened yet. Or they are very rare and so far away, maybe millions of light years away, that the limits of how far they can reach are very low compared to the size and distances in the universe. The aliens might not have reached the technological level required for space travel, either due to being a relatively young civilization or prioritizing different areas of development. Their advancements might focus on immediate planetary issues like climate control, food production, or healthcare, leaving less emphasis on space exploration. It's also possible that their society values introspection, art, or spiritual growth over technological conquest and exploration. Or they may have a culture with a strong aversion to risk, discouraging potentially dangerous endeavors like space travel. Past catastrophic accidents or philosophical movements might have led to a cultural consensus against space exploration. Another aspect to consider is resource scarcity. Essential materials like rare metals, critical for building spacecraft and advanced electronics, might be scarce or non-existent on their planet. Alternatively, if those resources are present on their planet, they could be so deep underground that they've never had the chance to discover them. Additionally, they might lack access to high-density energy sources required for rocket propulsion, such as fossil fuels or nuclear materials. On Earth, oil and gas are formed from the remains of ancient marine organisms subjected to heat and pressure over millions of years. A planet with similar conditions, including the presence of life, organic matter, and the right geological processes, could potentially have oil and gas deposits. However, this relies on several factors. Presence of organic matter. The planet would need to have had abundant organic life in the past. Geological processes. The right conditions of heat, pressure, and time would need to be present to convert organic matter into hydrocarbons. Chemical composition. The planet's chemical makeup would need to support the formation of hydrocarbons. Given the vastness of the universe and the diversity of planetary environments, it's conceivable that some planets could have oil and gas, but this would likely be rare and dependent on specific conditions. Another way of seeing things is that they might believe in minimizing their environmental footprint, extending this principle to space exploration to avoid contaminating other worlds. A philosophical or religious doctrine might advocate for non-interference with other potential life forms or celestial bodies. Alternatively, the use of massive resources for space travel might be seen as unethical when those resources could be used to improve life on their home planet. Another theory is that aliens might not be trapped on their planet, but trapped in their solar system or the immediate vicinity of their home star. The issue that prevents an alien civilization from venturing too far from their home planet, even if they developed advanced spacecraft, might be that the speed of light, as a universal speed limit, is very, very slow and poses significant challenges for interstellar travel. The vast distances between stars mean that traveling at or near the speed of light would still take years, decades, or even centuries. Reaching speeds close to the speed of light would require immense amounts of energy and create substantial technical challenges, such as dealing with the effects of extreme acceleration on both the spacecraft and its occupants. At relativistic speeds, time dilation would become a significant issue. While time would pass more slowly for those on the spacecraft, many years could pass on their home planet, creating profound social and psychological implications for any travelers and their society. The implications of this reality would be that being confined to their planet would necessitate a high degree of self-sufficiency. They would likely excel in sustainable living, renewable energy, and environmental management. Their technological and scientific advancements would focus on solving planetary challenges, leading to potentially unique innovations that might differ from those driven by space exploration. Isolation would significantly shape their cultural and philosophical outlook. They might develop rich cultural narratives and philosophies centered around their planet and its unique characteristics. This introspection could lead to advanced social systems, arts, and sciences tailored to their specific needs and environment. Overall, the inability to leave their home planet would create a unique civilization with distinct technological, cultural, and philosophical characteristics. Their evolution would be heavily influenced by the constraints of their environment and the necessity to find innovative solutions to remain sustainable and thrive on their home world. So what do you think about these theories? Do you think they are possible, or do you have another theory? Feel free to leave your thoughts in the comment section and hit that like button if you like this video. It helps me stay motivated and make better videos in the future. Also, maybe consider subscribing so you don't miss out on future videos. Stay curious, and see you in the next video.